Hey guys, Jay from RS Garage. Today I'm going to screw together this Mazworks Pro Street Billet 2JZ. It's got a 90mm Brian Crowder crank, a set of BME aluminum connecting rods, and a set of CP pistons. It'll give us an opportunity to discuss the pros and cons of a billet engine block versus a cast engine block. This block is a 2-bolt main design. The caps are doweled and are held in place by an ARP half-inch stud. This block has been used before, and as you look down the mains and look at the saddles, there isn't a lot of trauma going on. The cap is held in place pretty well with the 1/2 inch bolt. There are some aluminum blocks on the market that use more hardware to hold the cap in place. Keep in mind, if you have too much hardware on the piece of aluminum, it's going to cause distortion. So with this 1/2 inch stud, the mains keep shape well and it keeps the cap from walking around. So I've got a good amount of experience with this particular engine block. When I was at my old place, we needed a billet solution. It was before the Dart was available, and I talked to Mark Mazworks about it, and a few weeks later he said, "What do you think about this?" And it's been a pretty good design. We've been sixes with it. I've been out to Bonneville with it. You know, it's been a good engine for us to campaign. Now, the market's changed quite a bit in the 4 or 5 years that have gone by, so now there's a handful of other billet blocks on the market. Most of them are going to be a dry sleeve design, where this engine, if you take the sleeves out, it looks a lot like a Honda K-Series or B-Series while it's being sleeved. It's just a cavity that MID sleeves are pressed into. So there's water flowing around the sleeves. When you get into a dry sleeve installation, they have the sleeve entombed in aluminum. It's pushed down into the block, and if the water is jacketed around that, they do machining doors on each side of the block, and they cut where there's water getting access to the aluminum that's on the outside of the sleeve, but the water doesn't go directly on the sleeve. Now, it's a race engine, so depending on what you're doing with it, that may not matter at all. And if you're using an alcohol-based fuel, the tendency for the cylinder to maintain temperature control is pretty good, especially on methanol. So there are a lot of dry engines that don't have water at all in them. And then one step above that towards a street car would be a engine that's been dry sleeve, but it's got water jackets that are accessible through the sides of the block through those doors. So if you look at like a Bullet engine, they have these big windows on the side of the block that's held in with a bunch of screws. And what they're doing there is they're using the CNC machine to remove material on the sides of the aluminum that the sleeve is entombed in to try to maintain cooling. And then if you go one more step towards a street car, you have a wet sleeve design, which this is basically a wet sleeve design, but I would call it like a half fill, because there isn't water exposed to the whole cylinder like there would be on an OEM 2JZ or a Dart 2JZ. So it's still a bit of a hybrid. It's still very much a racing engine. But we've had good experience with it. We used it on drag week, extensive amount of street driving. There's some guys out there in the field that have a good amount of street driving on theirs too. So it's a viable solution. Mark does them in fairly low production numbers, so you have to wait till he runs a batch in order to get your hands on one of them. So I would say they're not as accessible as one of the other billet blocks on the market, but it's supply and demand. But it's been a good engine for me, and I would continue to use it and recommend it in the future. Now this is a 90mm standard weight crank. Brian offers them in standard weight and lightweight, but not in a 90mm. Lightweight cranks are available in 94mm and 96mm. And if you're thinking about whether or not you should buy a lightweight crank or a standard weight crank, it's kind of anybody's game. I've had a lightweight crank in my car in a 94mm configuration, and now it has a 96mm configuration. I've used the lightweight crank around 1500 wheel, doesn't have any problems. The old school thought is the material is the absorber of the harshness and vibration and mishaps that happen to your engine. So the more material you have, the stronger the part could be, or the stronger the part is. And when you get into reciprocating mass in different realms of racing, mostly naturally aspirated road racing, lightweight reciprocators are very attractive. So you'll get guys that go light, and the parts work well. I've only seen one lightweight crank break, and the guy had a very heavy clutch and he was drifting. So he had a 96mm stroke and a big high mass clutch assembly, and he's clutch kicking the thing at 8,000 RPM and it broke. So fortunately for him, it didn't tear the engine up too bad because it just started making noise, which is really lucky. But it had split as you come from the main and go up to the rod journal. That's the narrow part. And as you add stroke and the center line of the rod journal gets farther from the center line of the main journal, you're asking that material to do more work. And you can get into some breakage on extremely lightweight parts. But in the JZ realm, depending on what you're doing with the engine, I'll almost always reach for a lightweight crank because it's less mass. The engine's going to be able to accelerate that mass faster, and with regular use, I've not had any problems. So give something to some people, they can break anything, but I'm not afraid of the lightweight cranks. It's just that in this 90mm configuration, it's only available in standard weight. And generally, as you get into that 10,000 RPM, 50, 60 plus pounds of boost, those guys are all going to lean on this 90mm crank because it's a reasonable compromise between the factory 86mm stroke and something like the 94mm stroke. And you're still able to capture the piston completely in the bore at bottom dead center and have the additional stroke for spooling the turbo and having more average power. So 90s are a really good compromise if you're just going to be drag racing. For comparison, I have a 10mm ARP stud. This is going to go in a OEM 2JZ engine next to the 1/2-inch stud that's holding the cap in place on the MazWorks block. So quite a bit more material, quite a bit longer. This 1/2-inch stud is extending down into a large block of aluminum that extends across basically the middle of the block. So the head studs go down into a chunk of aluminum and the main studs go down to a chunk of aluminum. And it also has a bull nose. So when you install this stud, it stops on the bull nose, leaving the threads neutral. Often you'll hear me talk about not tightening the stud into the block because you want the threads to be neutral. That way you're loading the stud evenly as you tighten it up. The bull nose is kind of a cheat. Now, some engines you can't use a bull nose and some engines you can, but when Mark designed this piece, he designed it with the bull nose stud in mind. As I was measuring the bearing clearance on this engine, I noticed that I was getting a little turning out of the washers. So quick little work on a belt sander and just rough up the bottom of the washers are going to hold them in place on that steel cap, keeping the washer from rotating. So it's kind of an old school trick, but it does work, and it will keep the washer from moving around and altering my balance between target torque and the clamp load on the fastener. With the crankshaft in the block, it's time to move on to pistons and rods. For this particular engine, I've got some BME aluminum rods. Now, in case you haven't heard of BME, BME is Bill Miller Engineering. Bill Miller has been in the game longer than I've been alive. A lot of top fuel experience, pistons, pins, rods, superchargers. And through the channels of racing out at Bonneville, I've come in contact with Bill Miller. And it's been pretty cool because when you have a guy that's been in the game, you know, nearly double the time you've been alive, he can teach you stuff. So Bill Miller has shared some pretty interesting information with me that's helped me move my career along, and in turn I throw him some business. Now, I have a long-running relationship with R&R connecting rods, and in the time I was using R&R, I damaged one rod, and it was just hammered, and it was my fault. I had a secondary injector not come on. Car went 600 feet, blew a hole in the piston, blew a hole in the cylinder head, elongated the small end of the rod. It was a pretty spectacular mess. I have been able to close up the big end of the connecting rod, which is an interesting talking point. The vertical oil clearance on an aluminum connecting rod has a minimum, and the reason why they specify a minimum of, say, 3/1000ths of an inch is if the engine is seeing excessive cylinder pressure through detonation or misfires, it can actually close up the big end of the connecting rod. And it's a conversation that Mike from R&R and I had years ago. And he said, you know, are you closing the rods up? And I said, no. And he says, well, you're probably not running it hard enough. And as we continue to increase boost pressure with an ethanol-based fuel and an air-to-air intercooler, we ran out of air density and started to close the rod up. And I said, hey, Mike, I finally got to the point where I put the rod in the engine at 3/1000ths, and I take it back out, and it's 2/1000ths of vertical oil clearance. And while it's not something you want to do, it's an interesting tuning tool because it's another thing that's telling you about how you're running the engine. Anyhow, the BME part is a forged rod, and with that being said, Bill Miller thinks it's about 25% stronger than something that's made out of an extrusion. So there's that. For this particular engine, you know, Shannon's not really running a ton of boost. His car goes mid-4s to the 8th. His R&R rods came out of the engine fine. Again, I'm just doing some business with a guy that I enjoy having conversation with, but pretty neat part nonetheless. It's going to get a set of BME pins also, that C300 pin, and a set of CP pistons that are a fairly mild 9-to-1 compression ratio. Shannon's looking for longevity over max power, and you know, he's just a guy that's going to go run his car and have some fun, so he doesn't need that last little bit of power. And he's also still running the engine on ethanol fuel, so you wouldn't really get into the realm of what you can get away with methanol with ethanol. So just some food for thought, but get these things put together and get them put in the engine. far as the head gasket system on this engine, it's using a fire ring head gasket. So the copper gasket that you see here is going to retain the coolant that's flowing up through the block into the cylinder head and back into the radiator, and managing the oil that's going to the cylinder head and coming from the cylinder head. The combustion sealing will be done by these copper alloy rings. So this is a solid ring and it's 3 thousandths thicker than the head gasket. So it's just going to be compressed into the deck of the cylinder head, but it doesn't really give. So there's a certain amount of distortion that comes along with a system like this. And that distortion is going to be present in the deck of the head, the deck of the block, around the combustion chamber, in the valve seats. There's no real way to get around it. You're just smashing metal together, but it does work fairly well and is a long-term solution as long as you can get the oil and water sealed up on the copper gasket. Now, as far as that goes, we use a 2-part epoxy that I get from my buddy Tom at Nelson Racing Engines out in California. He turned me on to a product a few years ago. However, he won't tell me what it is. He just sends it to me as I need it. So if you need to buy some of it, you may want to reach out to him. As far as the installation goes, it's a bit messy because I need to get sealant over the entire surface of the head gasket, get the head studs in the block, lower the head gasket on, then I can put the head on. The head itself is just machined flat, so nothing is done to the cylinder head deck surface. It's done as you would use a traditional MLS gasket on, but there's a lot of work and machining that goes into this firing system. Now, the ease of this system in comparison to using a steel wire that's either in the head or in the block is these pop right out of the deck. So you don't have any danger of chipping the cylinder head and or the sleeves of the block when servicing the engine. You pull these out, you resurface the block, you resurface the head, you cut the receiver groove that retains the ring in the block, and you move on with a new engine. Now, for those of you that watched the teardown video on this engine, the valve train was in distress, and we took the head apart. There were some valve stems that were worn. The buckets were pretty beat up. The cams had some ill markings on them where it had, the bucket had worked its way through the, I believe it's a PVD coating on the cam. And once you're through the coating, you're just steel on steel, and then it's going to start making a mess. And it's just not stuff that I would want for my customers, that's all. And it's okay for me to want more for my customers based off of my own experiences and testing. So Shannon can take the engine home and run it for a period of time and pull the cam covers off of it and just kind of take a look and see how things were living, because in the teardown video there were some marks on some of the lobes that it all just kind of goes downhill from there. And I don't want to take the position that steel cams are a bad thing, because steel cams in a roller environment are a great thing. And steel cams in this environment, maybe there are some recipes that could be made to work. But when the biggest voice in the community puts together a product and that product has problems and he reacts the way he reacts, it's kind of like, well, where's the gain? Like, if you were going to take a risk, you'd like to have a gain. So I just don't understand what the upside is to using a steel cam in a flat tappet or flat follower operation. It doesn't make sense to me. I don't understand the gain. Now, the manufacturer may see the gain because of lead times or shipping risks or quantity, available quantity. When you work in billets, just like this engine block, it's easy to make 5 of them. You don't have to make 500 of them like you do with a casting. So maybe there are some advantages. I just don't understand the advantages that the end user gets to experience. So for me, it's like I can reach for a set of BC cams or a set of Kelford cams, and you kind of like, you know what you're getting and you know what to expect. And you have some flexibility, because if everything is perfect in valve train, if all 24 of these valves are always operating in complete harmony, it's easy to forecast an outcome. But that's just not how reality works. I mean, there are going to be times, like when I went out to Texas to help Jared, I upload the log that's in his computer, and there he is, 10,500 RPM doing a burnout. And it's like, well, how do you really plan for those events? And the customer deserves, it's part of the responsibility of an engine builder or a tuner is to give the customer some grace room where if things aren't perfect, the customer may not incur a failure, and they may not have to experience the downtime, and they may not have to spend the money because they have a little bit of flexibility. And in the realm of flat tappet chilled cast, you get that. The camshaft will go through trauma and live to tell with less ill effect than a steel cam, because once you get those marks on that steel cam where it's got that horizontal line across the lobe and it starts dragging material up to the top of the lobe, and then it starts to cut the bucket, it's kind of all downhill. And if you do manage to damage a flat cam, especially if you're using it, if you're on break-in with a used lifter and you're running the lifter in, new camshaft, previously damaged lifter, you could wipe a lobe off of a flat tappet cam, and it has to make its way, the material has to make its way through the oil pump into the oil filter, and then things kind of go downhill from there, because the owner then realizes that he has a problem, he looks into it, and he's wiped the camshaft. Now, I've never wiped the camshaft on a JZ in a chilled cast configuration, but I have seen it. But I don't know the exact circumstances that the engine was going through, so it's hard to comment on it. But it's just about trying to provide the best product and the best value for the money, and it's just my opinion, and I'm okay if I'm wrong about it, but chilled cast sure seems the easy way to do it. That's as far as I need to take this engine. It can go back to its owner where he can put on his water pump, timing belt, cam covers, and get it back in the car and get back to the track. Pretty exotic piece. I know that billet blocks aren't really new to our scene. Now it's been quite a few years, but back at my old place, we proofed this engine through various drag week events and going 6s in the quarter mile. It's a pretty neat piece. I've got a couple more of them here right now to assemble for other customers. So a low production item as you'd expect from a billet, but it does suit the needs of some specific users. Hope you've enjoyed the video. Thanks, and I'll see you next time.